Okay, this is chapter 7.1, inverse variation. The essential question is, how can you recognize when two quantities vary directly or inversely? So what you will learn in this chapter is how to classify direct and inverse variations and how to write inverse variation equations. So let's take a look. Okay, first we have to talk about what an inverse variation is. Okay, so core concept says inverse variation. Two variables, x and y, show inverse variation when they are related as follows. If y equals a over x, some number over x, where a doesn't equal 0, because if a was 0, 0 over x is just 0. The constant a is the constant of variation, and y is said to vary inversely with x. So if I have an equation that is equal to or y equals a over x, and a equals 4, then that's the same as saying y equals 4 over x. Oops, I'm not writing an a. 4 over x. Okay. Well, this can be rewritten as y equals 4 times 1 over x, if you will. And since x is in the denominator, it's inversely related to y. It's an inverse, remember, because y is y over 1. So if you have y over 1 and 1 over x, then they're inverses. And that's where this comes from. Okay, example 1, classifying equations. So it says to tell whether x and y show a direct variation, an inverse variation, or neither. So A, x times y equals 5. So what you want to do is solve for y. So I'm going to divide both sides by x. These cancel, and I get y by itself equals 5 over x. And remember, it's y equals a over x, where a cannot equal 0. Well, a is 5, so this is an inverse relation. Okay. B, y equals x minus 4. Well, if I solve for y, well, it's already solved for y. So there's nothing I can do here. And x is not in the form of a over x, so this is neither. Okay, it's not an inverse, it's not direct. And let's look at C. You're probably wondering, well, what's a direct variation? We haven't done one of those. Well, here we go. Y over 2 equals x. So if I multiply both sides by 2, 2's cancel, and I get y equals 2x. So since y is equal to a multiple of x, in other words, it's linear, then that is a direct variation. Okay, so that's how you determine direct, inverse, or neither. Inverse is in the form of a over x, and direct is in the form of a times x, if you will, some coefficient times x, or mx. And this is a linear equation, but it's got this minus 4 here. So having a y-intercept, and remember, probably from, I can't remember if it was 6th grade or 7th grade, a direct variation equation has to go through the origin. So when you plug in 0, you get 0. So 2 times 0 is 0, so y is 0 when x is 0. If I plug 0 in here, it'd be y equals -4. So it'd be -4, or 0, -4, okay? So direct variation has to be going through the origin. X and y are at the origin 0, 0. So this is a direct variation. Inverse is a over x. Now you should be able to do problem numbers 3, 4, and 8 in the exercises. Okay, example 2 is classifying data. So now we don't have an equation, we have a table of values, x's and y's, input and output values of a function. So it says to tell whether x and y show a direct variation, an inverse variation, or neither. So in order to solve this, what we have to do is find the product of x and y and find the ratio y divided by x. Okay, so if I look, 2 times -12 is -24. 4 times -6 is -24. 6 times -4 is -24. And 8 times -3 is -24. So the products are constant. Okay, so if you have a constant product, that's one thing you need for a direct variation. I mean inverse, I'm sorry, inverse variation. So then when we take y divided by x, -12 divided by 2 is -6. -6 divided by 4 is a -3/2. -4 divided by 6 is -2/3. And -3 divided by 8 is just simply -3/8. Okay, the ratios are not constant. Okay, so the products were constant, the ratios were not constant, and therefore, x and y are inverse variations. So if x times y is constant and y divided by x is not constant, then it's an inverse variation. Okay, so that was A. So now let's take a look at B. Okay, so now let's take a look at B. So we have a table 1, 2, 3, 4, which is constant 1 to 2 to 3 to 4. So it's adding 1 every time. So that's not a constant multiple. 1 times 2 is 2, but 2 times 2 isn't 3, it's 4. So this is just increasing by 1, and this is increasing by 2 squared is 4, 4 squared is 8, 8 squared is 16. So that's what we take a look at. So it says to find the product. What we should do is find this just like we did in A, find the product of x times y. So 1 times 2 is 2, and 4 times 2 is 8, and 3 times 8 is 24, and 16 times 4 is 64. Okay, and then we take y divided by x. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3 is 8/3, and 16 divided by 4 is 4. So the products are not constant. See how this is -24, -24, -24, -24? They're inverses because the products were constant and the ratios weren't. This is the products are not constant and the ratios are not constant. So therefore, x and y show neither a direct nor an inverse variation. So this is how you determine that. Multiply and divide your x's and y's. And so now you should be able to do problem numbers 11 and 12 in your exercises. Okay, so here's example 3, writing an inverse variation equation. So it says the variables x and y vary inversely, and y equals 4 when x equals 3. So we already know that there is an inverse variation. We're told that right here. It says to write an equation that relates x and y, and then find y when x equals -2. So the first thing we're going to do is we're going to write the standard equation, which is y equals a over x. So we have a y, 4, we have an x, 3. So now you just substitute your givens. So that becomes 4 equals a over 3. Okay, and then we solve for a by multiplying 3 on both sides. 3, not 2. And these 3's cancel, and 4 times 3 is 12. So 12 equals a. So now I have y equals 12 over x. So there is my inverse variation. Okay. The inverse variation equation is y equals 12 over x. And now we have to find y when x is -2. So now we just substitute that in. So y equals 12 over, and x is -2. So I put a -2 here. So simplifying that, a positive divided by a negative is negative. 12 divided by 2 is 6. So when x is -2, y is -6. Okay, so now you should be able to do problems numbers 15, 16, and 20 in the exercises. Okay, so here's example 4, modeling with mathematics, a real life situation. The time, t, in hours that it takes a group of volunteers to build a playground varies inversely with the number of n of volunteers. Obviously, the more volunteers you have, the less time it takes. So as the number of volunteers increases, the time it takes to build it decreases. That's why it's inverse. One's increasing, one's decreasing. It takes a group of 10 volunteers 8 hours to build the playground. So there's the key right there. Okay, 10 volunteers, 8 hours. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. So I have the table already over here. So what we want to do is erase this dot I just placed there for 1. Okay, so 15 and 20, 25, and 30. So there's our table of n values. That's a number of people, volunteers. And now we have to calculate how much time it takes. So we want to use the equation y equals a over x, okay? And then we want to change it because time t in hours, it takes a group of volunteers. That is going to be our y. So now t equals a over, and it's not x now. So this is our x and this is our y. So where there's an x, you put an n, and where there was a y, we put a t, okay? Pretty simple, right? This is x, this is y in a table. In this case, nt. So n replaces x, t replaces y. Okay, so I'm going to erase this. We're going to use y equals t, or I'm sorry, y or t equals a divided by n. I guess I'll just leave that there. All right, so what I'm going to do is I'm going to take my given 8 hours is time, so that's my 8 equals a over the number of volunteers, which was 10. And I'm going to solve for a, just like we did in the last problem, multiply both sides by 10, and 80 equals a. So I found my a with that one value of time and number of volunteers. And so now I know a is 80, so I'm going to take this equation here, and I'm going to write t equals 80 over n. And it's that simple. So then I'm going to substitute in 15. So I'm just going to use my calculator here to make life easier. So let me get that ready here, clear, and do this. All right, and just move that over a smidge. Okay, here we go. So I want 80 divided by 15. So t equals 80 divided by our n, 80 divide 15, and that's going to give me 5 1/3. Okay, so then I just get rid of that, and 80 over 15 is 5 hours, and 1/3 of an hour is not, it's 1/3 of 60, which is 20 minutes. Okay, keep that in mind too. And we just keep doing that. So for 20, we're going to do t equals 80 over 20. Well, that reduces to 4. That I don't need my calculator. That's just simply 4 hours. All right, and then 25, what we're going to do is say t equals 80 divided by 25, and I'll just do that over here because it's a decimal. 80 divide 25, and it equals 3.2. And 2/10 of an hour is 12 minutes. Okay, 3.2, 2/10, 1/10 of an hour is 6 minutes. So 2/10 is 12. Okay, and then 30, we're going to do t equals 80 divided by 30, and that's going to reduce to 8/3, which is 2 2/3, or 2 hours and 40 minutes. So I didn't need my calculator for that one. 2 hours and 40 minutes. So as the number of volunteers increases, the length of time it takes to build the playground decreases. So this is an inverse variation. Okay, so now you should be able to do problem numbers. Oh wait, did I answer the question? Hang on. What happens to the time it takes to build the playground as the number of volunteers increases? We answered that. As the number of volunteers increases, the time it takes decreases. Okay, and then did it say anything else? Did we have to calculate anything else? I always check to make sure I answered the question. Make a table, and we did it for all the values. What happens to the time it takes to build a playground and a number of volunteers increase? We answered that, and I guess that's it. Okay, so now you should be able to do problem number 25 in your exercise is. Okay, so that brings us to the end of chapter 7.1. Here are the exercises I want you to try, and I threw in 34 and 35 for good measure because it's always good to review old stuff.